We're back. This done. I'm not gonna throw it. I'm gonna set it lightly down. I got a new computer that's working from Lake County Schools. Thank you. And which means we're back, and I've got my notes available to me to be able to pass along to you. So again, we're back. First, a little more math, a little more fun times going on here. While we were gone, I have attained another math championship belt. I'm just saying, I was just the Algebra 1 champ. Now we're going for middle school math champ. I've got a feeling we're going to find some more belts pretty soon. I'm just saying, because, you know, the champ right here. Anyway, of course, it wouldn't be a math day unless we were... Don't forget about Dre, guys. Just don't forget. You don't forget. Time to open up some stuff, because we need to do something. We got to get back on this. What do we got here? We got a little DC figurine. Who do we got? Oh, Green Lantern. Ryan Reynolds' most awful, awful movie ever. Just kidding. But yeah, seriously, it was bad. You can go set up here by Max Scherzer. Sweet. That's gone. What else? Oh, we got Trolls. Trolls just came out. So we got a clip of some sort. What we got? See? Oh, we've got Delta Dawn. I got a feeling this is the country one. Pretty sure. Feels right. You can sit up here by Monty Python and the Holy Grail, because of course. And a baseball player too. And remember, if we find an Astro player, we throw it away because we're not cheaters here. Oh no, we're good. Tony Bellinger, we're good. He's a good player. We can like him. All right. You can sit up here. We're good. Look at that. Things are running right by. Disney pins, of course. We got a little Maleficent head. Looks a little scary. Stitch, hanging out for today. The Jolly Roger. Little Peter Pan action. Got some Disney pins. I guess still missing the Disney life, but you know what? We're doing what we can. Staying safe, staying away from people as much as possible. Some quotes, of course. Can't go on without quotes today. From yesterday, which is my birthday. I'm getting old. My decision-making skills closely resemble those of a squirrel when crossing the street. It's probably not the best, but you know, it's okay. And today's quote of the day. Do you ever forget to hide your expressions for a minute, and then you're like, I didn't mean to make that face out loud? That might have happened to me in a meeting earlier today. All right. So we got quotes done. We got some stuff opened up. Clearly showing off that I'm now not just the Algebra 1 champ, but the middle school math champion of the world. Let's go. I think it's time to do a little bit of math. Let's go. All right now, Branch, Poppy, pay attention. This is going to be on the quiz. We're back. Ready to go. Algebra guys. Today, a little bit of review, because coming up in Edgenuity, we're going to have a little bit of work with solving systems of equations that include quadratics and linear equations. So, figure might as well do a little review of solving a system of equations. First off, using the substitution method. So, again, why do we use the substitution method? Why is that available? Remember, to me, it doesn't matter which method you choose. But substitution comes in handy most often when we've got a variable already solved for, like in this first problem here, where we already have one of our variables by itself and isolated on one side of the equation, or when it's easy to get a variable by itself. So in this case, we've got y equals 3x plus 2 and x plus 2y equals 11. We need to find out that order pair, that x and y value, that would make these both equations true. So to do that, we're going to start by substituting. What we're going to substitute? Well, since I know that y is equal to 3x plus 2, I can substitute that in to the other equation. Okay? Now, is y the same? Do they look the same? No, but they have the same value for this equation. So I can rewrite my equation as x plus 2 times y, which y is equal to 3x plus 2 equals 11. Now, we got a nice easy equation with just one variable. Simple enough. We're going to do solve for x. So, first thing we have to use, sing it with me. Wait for it. 3, 2, 1. The whole distributive property. That's right. We're going to use that here. We have x plus 6x plus 4 equals 11. Now, combine like terms. X plus 6x is 7x. Plus 4 equals 11. Subtract 4 from both sides of the equation. 7x equals 7. Divide both sides by 7, and we get x equals 1. And that's great. That's a wonderful answer. But is that the only thing we got to do here? No, of course not. We've only found out what x equals. We've got to find out what y equals as well. So since I know that x is 1, I can take this value of x, go all the way back up here to my first equation. I'm going to substitute in 1 for x since that's the value. Now I've got y equals 3 times 1 plus 2. Now we just got to solve for y. So y equals 3 times 1 is 3 plus 2 equals 5, which means my solution for this equation is the order pair 1, 5. If x equals 1 and y equals 5, it will work in both equations. Perfect. Now that's great, but sometimes we're not given an equation where one of the variables is already solved for. Like over here where I've got x minus 2y equals negative 6 and 4x plus 6y equals 4. Now, we don't have a variable already solved for, but I do notice that x has a coefficient of 1 in this first equation, which would be easy to get x by itself. Simply by adding 2y to each side of this equation, we get x equals 2y minus 6. That helps. That puts me in a position to be able to substitute in this case for x into one of my other equations. So now I've got 4x, well x equals 2y minus 6 plus 6y equals 4. Go back to that whole distributive property. 8y minus 24 plus 6y equals 4. Combine like terms. 14y minus 24 equals 4. You get the variable isolated by adding 24 to both sides of the equation. 14y equals 28. Divide by 14. Y equals 2. So again, we're halfway there. Do we have the whole answer? Not yet, but we're getting close to it. We do know that y, in this case, is 2. Now remember, I guess got to go in the y position here for our ordered pair. Don't want to mix that up. Now again, we know what y equals. We're going to replace it in our equation here. So x equals 2 times 2 minus 6. 2 times 2 as 4. Minus 6 equals negative 2. And so that is the solution for the second equation, second system of equations. Again, the process is not very complicated. We also will have elimination, which we'll go over in the next video. But substitution method does work. We're going to look at one more problem, and then we're done for the day. Back in a second. Again, as always, here to support the video. Even though it's his birthday, Anthony here, appreciate it. Ross, Nelson, Rebecca, coming to show up, learning a little math with you guys today, because everybody knows math, most important subject. I mean, I'm not bragging, but I mean, it's a little braggadocious. I'm okay with that. But they're here. Thank y'all. Ready for another problem? Oh, it's a word problem. Yes, the best, right? You're all excited about word problems, right? Right? Whatever, it's fine. I like word problems. So we're going to go over one here. Jeff has $4.50 in quarters and dimes. He has 3 more dimes and quarters. How many quarters does he have? All right. Well, we have nothing here yet, do we? But we do know the topic is solving a system of equations. We're going to use a little context clue here. I see in this problem 2 equations we could actually write that would help us figure this out. So to start off with, we're going to use some variables here about D can be dimes and Q for quarters. I know, very creative, right? If I know that he's got $4.50 total, I do know that quarters have a value of 25 cents each. So if I have 0.25 times the number of quarters, that will tell me how much money he has in quarters. And a dime is 10 cents. So if I have 0.1 times D, that will tell me the amount of money I have in dimes. And we know he's got $4.50 total. Okay, that's helpful. We also know, though, that he's got 3 more dimes than he has quarters, which means that the number of quarters plus 3 should equal the number of dimes he has in total. That's 2 equations, and we have 1 equation solved for a variable. We can use our substitution method. So, move this over here. 0.25q plus 0.1 times q plus 3 equals 4.5. Use our distributive property here, our good old distributive property. 0.25q plus 0.1q plus 0.3 is 4.5. Now, we can combine our like terms and get this 0.3 removed from the left side so our variable is isolated. We end up at 0.35q equals 4.2. Now, here, all we got to do is divide by our coefficient. We find out that q equals, wait for it. Calculator out, type it in. No, it's not 11. You're close, not 11. It's 12. 12. Now, just to be sure that's right, we know he has $4.50 total in money, right? Well, if he has 12 quarters, that means he has $3 in quarters. And we know that he's got 3 more dimes than he has quarters, so 12 quarters means he has 15 dimes. The question is, if he has 15 dimes plus $3, will that equal $4.50? Of course it will. It's 3 plus 1.5 equals 4.5. Sweet. Look at that math all working out so nicely and easily. And we're going to use this, and we can use this method of solving a system of equations. We'll use elimination tomorrow, kind of my personal preference, but whatever, to each his own. And we'll be right back with one second with just a little bit more after this.
2,000 years later.
Again, another day. We're back. All week long we'll have videos, thankfully, as long as my computer does not break again. Fingers crossed. Knock on wood. Not going to happen. It's not going to happen. No way. Right? Anyway, looking forward to the rest of the videos this week. Again, if you have any questions on topics or things you want us to go over or some of these videos, please email me. Let me know. Son of the teacher of the universe right here, helping you out with this math. We'll see y'all next time.